Now let's see how to solve this shared data problem. The first method of solving the shared data problem is to disable the interrupts whenever we want to run the task code and enable the interrupts after completing our task code. Let us look into the example. So here this is as usual the interrupt routine. Now before except this disable and enable, the rest of the code is same like the previous one. So prior to entering into these sets of code, we are going to start. So here disabling the interrupts prior to entering into this code, and after completion of reading the two temperatures, enable the interrupt. So here there will not be any change in the temperature values, and because interrupt cannot occur here, we have disabled the interrupts, and after reading both the temperatures we are going to enable that, and finally we are going to check whether both the temperatures are 0 or not, that is the difference between the temperatures is 0 or not, and then it's going to set the howling alarm. This is one way of doing this. Let us see the equivalent assembly level code for using this disable and enable in figure 4.8. So this is what it happens. This is the assembly language equivalent of the previous example. So disabling the interrupt, then moving the temperature, first temperature into register R1, second temperature into register R2, so that the interrupt cannot occur between these two instructions, then enabling the interrupt. Finally subtract those two to check whether it is 0 or not. If it is 0, that means difference is 0, means both the temperatures are same. So this is one way of solving the shared data problem using disable interrupt and enable interrupt. Now let's look into what is called atomic and critical section. A part of a program is said to be atomic if it cannot be interrupted. That means if the part of the program gets interrupted, that results, if that is going to result in shared data problem, that should not be interrupted. For that purpose only we used disable interrupt and enable interrupt. Also sometimes atomic means it is not a part of the program that cannot be interrupted, but rather to mean that it cannot be interrupted by anything that might mess up the data. That means suppose in the above example, here we are reading the temperatures. If some part of the interrupt is going to update the pressure, date or time of the nuclear reactor, that is not going to interfere with these two values, isn't it? That means the interrupts which are not going to mess up the data within these registers can occur. That is what is meant by atomic and critical section. Now let us look into another example to see how shared data problem occurs and how it can be solved. This is an example wherein the time is going to be updated as soon as a second is passed. That means if second is greater than 60, minutes is going to be incremented. If minutes is greater than 60, hours is going to be incremented. This is what the routine is, and this is the function which is going to count the time that has been elapsed since midnight. So L seconds since midnight is the time that is going to read how much time has been elapsed since midnight. So for that we need to have the values of the seconds, minutes and hours. So as and when this function is called, it is going to read the seconds from this above interrupt, and then minutes and then hours. Now here also shared data can appear, though all these things are going to be calculated in a single instructions. We have seen that this is going to, a single instruction in C language is going to be converted into several instructions in assembly level language. Let us look into it now. So here when it depends on the compiler whether seconds are going to be read first, minutes are going to be read first or hours are going to be read first. Let us assume, suppose that the time is 3:59:59, that means 3 hours 59 minutes and 59 seconds. Now let us say that the function is going to read. It reads the hour as 3 and minutes as 59 and seconds as 59. But before it reads the minutes, first it has read the hours as 3 and an interrupt occurs. It is going to service that interrupt and later it is going to read the minutes and seconds. By the time it reads minutes and seconds, time would have been updated to 4 o'clock, 4 hours, 0 minutes and 0 seconds. Now hours has already read, it is going to read the minutes as 00 and seconds as 00. That means minutes is now 00, seconds is 00 and the time looks like this. But this is not the actual time. Time is 4 o'clock, but it is going to read it as 3, almost an hour is off from that. It is not desirable. So this is what happens when the variable is shared. This is a shared data example. This is how the shared data appears. Now let us look into the solution for it. We know that the solution is by disabling and enabling the interrupts. By using this disable and enabling the interrupts, we can avoid the interrupt interrupting within this instruction. One problem of using this kind of disable and enable is when we use this enable, all other interrupts are going to be enabled even if they are not supposed to intervene. Maybe it's not that we are enabling the interrupt that should not interrupt between, which is going to alter or mess up with the values within the hours, minutes or seconds, but it is going to enable all the interrupts. So in order to avoid that, we can use a Boolean function wherein, see, the bool f interrupt state 0, that is, even if we enable the interrupt, it is going to enable the interrupts to the previous state prior to occurrence of the interrupt. That means only the interrupt which was not supposed to interrupt here is going to be enabled, not all the interrupt. This is a best solution for avoiding the shared data problem.